Get the show started here. My name is Travis Durick. I'm a product manager here at Peplink, and today we're here to talk about out-of-band management and specifically how Peplink can help you deliver a great out-of-band management solution for your customers. So as always, Peplink's mission is to deliver unbreakable connectivity anytime, anywhere. A lot of the times people think of Peplink as protecting your WAN connection, right? Protecting your internet connectivity. And so today we're talking about out-of-band management. So that can play out a little different than what you might normally think of using Peplink for, right? Out-of-band management is not intended to be the primary internet connection for a customer, but it's a vital connection regardless. And so customers still need that unbreakable experience. And we're able to deliver that in a manner that's cost-effective and straightforward to deploy as well. So Peplink is extremely well positioned to deliver a great unbreakable out-of-band management solution. If you're new to Peplink, welcome. And if you're not really familiar with us, I can talk on and on about who Peplink is and how great our solutions are, how great our products are, but hearing it from customers really matters the most. And so I like to point people to Gartner's Peer Insights page. You can check out all the different reviews on there. We've got stellar reviews up and down the business ecosystem, small companies, massive Fortune 50 type companies, all over the spectrum. So again, don't take my word for it. Go do some research on your own. And I think that's a best way to really get to know what people think of Peplink. So what is out-of-band management? Out-of-band management is pretty straightforward in concept. It's just a path into a remote network so that you can manage it, troubleshoot it. Again, it's getting that visibility into your remote networks. Now, typically this is done, as the name implies, out of band. So it's typically done outside of the primary WAN of that network. So it does two things. It gives you a boundary between your user traffic so that you're not commingling that management administrative traffic with your user traffic, so users can't access those types of management interfaces for your network infrastructure. And it gives you resilience beyond that network's primary WAN connection. So the whole point of this is to give you the ability to get into your network when something's wrong, right? If you have a problem on site, you don't want to have to wait to send people, drive them out, fly them out. You want to be able to dive in right away and figure out what's going on at that remote location. And so that's what out-of-band management is designed to do, give them that secondary path into the network so that they can troubleshoot things when things are just not working normally. Now, there's all types of things that you might need to do or you might want to do in this out-of-band management network. There's all types of devices or interfaces that you might be trying to reach. And so that could be serial devices. So there's all sorts of network appliances that have these command line interfaces on a dedicated serial console port. Could be a sensor. And it could also be just as simple as IP devices, right? It could be lots of servers have a integrated lights out port so that you can remotely reboot, do all kinds of system level functions that you might need to on that remote server. It could be a IP-based keyboard video mouse KVM switch where you can manage multiple PCs or servers. Could be multi-port serial servers, or it could just be as straightforward as logging into the network appliance's web interface. So out-of-band management isn't limited to serial, it isn't limited to CLI. Again, this concept can extend just into traditional IP devices as well. But again, it's providing that secondary path into that network. So if we look at just a real simple diagram here, here's a great example. Your customer may have an existing Cisco router or some third-party vendor network equipment that's already in place, right? They're not going to rip that out just to get out-of-band management. They just want to bring in a simple device, cost-effective device. It's going to give them a secondary path into that device, into that primary network device if they've got a problem at their network. So here you can see the Cisco router has an internet connection, and then it's also got a secondary connection to our Max BR1 Mini here. And that is connecting over 4G LTE. So if that primary internet circuit, could be MPLS, could be cable, DSL, whatever that primary connection is. If that fails, they need to get in and troubleshoot, right? And so that's where that LTE path comes in, and that's where the Peplink router comes in with some of our out-of-band management specific features. And the need for this is really broad, right? This could be enterprise often, it could be government, it could even be something as unique as military applications. Anybody who's got remote networks needs out-of-band management. And so this is a pretty universal need. So with that, I'm going to dive into 5 features that Peplink offers to make out-of-band management a lot easier for you. So the first one is the UART serial console. This is, oh, I jumped ahead too quick. This is the ability to bridge the gap from a serial non-IP device to your IP networks. And so with several of our models, we've got this built-in serial server functionality. And so we'll show you how that works and how you can use that. Now, extending that even further, we've got integration with our cloud management system InControl 2, so that you can access these serial consoles through our remote web admin system with InControl. So just making it even easier for you to manage these networks out of band. Next up, we've got our router command line interface. So the Peplink router itself has a command line interface, which you can use a variety of commands in there to do different out-of-band management activities. And so we'll show you that both directly into the router and again through InControl 2 using our remote CLI. Now, another request we see a lot, very often for out-of-band management networks is input-output functionality. So the ability to have simple sensors and simple events so that you can trigger different actions either automatically or manually remotely if you need to. And so this can be done to, turn a light on, turn an alarm on, turn a fan on, or tell you when one of those things turns on. So it just extends your capabilities even further into non-IP devices again. And then last, we'll talk about SpeedFusion and other VPNs, how you can integrate those technologies to make your out-of-band management much more secure and much more resilient. So we'll step through all of those in a live demo later on here, but next I'm going to show you all of our different devices that fall into the scope of this out-of-band management concept. So we've got several devices here. We've got our Max series of products and we've got our Transit series of products. And each of these models has specific functionality that'll help you when building out-of-band management networks. First up on the top left, we've got the BR1 Mini and the new BR1 Mini Core. If you're not familiar with the BR1 Mini Core, that is just a new version of the BR1 Mini that has removed Wi-Fi and removed GPS. So it's a slightly reduced feature set and it's a slightly reduced price. It's down to $249 for the MSRP on that one. So that's a great product. Again, if you don't need Wi-Fi or GPS. The BR1 Mini and BR1 Mini Core have a breakout module that lets you do the serial port functionality that we talked about. If we move to the right, we've got our BR1 Classic. This is very similar, but it has that serial functionality, and it also has the input-output functionality as well that we just briefly touched on earlier. We've also got the BR1 ENT and the HD2 Mini. Both of those have that serial functionality. Down on the bottom, we've got our Transit Mini with the serial and the I/O functionality, and then we've got our Transit and Transit Duo, which each have that serial functionality. So lots of models to choose from depending on the application, the environment, and really the goals of the customer, but lots of reasonably priced models that are going to stand up well and be a great foundation for an out-of-band management network. So let's look at the serial ports quick. They come in a variety of form factors on our products. We've got a terminal block form factor, which you can see here on the left. All you have to do is just direct wire that cable. The pinouts are labeled on the terminal block header there. So maybe you have to cut the end off the cable and wire them up to that terminal block, but real simple installation to get that serial port functionality working. On the BR1 Mini and the BR1 Mini Core, there's a breakout module that lets you split the LAN and console port. You can see that slightly on the top right there. There's a LAN console port. So that's a dual personality port. And if you add this accessory, then you get both functionality out of that single port. So you're able to maintain that Ethernet connection on the left port, and then on the right port, you would plug that into your serial device, so that router CLI interface. Again, I just talked about the BR1 Mini Core a little bit. Here's another look at that. Again, it's got that out-of-band management support, that dual personality LAN and console port there. And again, there's no Wi-Fi, so it's great for very security sensitive deployments where any sort of extra interfaces are deemed as a risk. So again, this is just a great little building block for your out-of-band management network. Now, a new product that we've got coming out, I think this will be out later this month or early next month, is our Max adapter. So this is Peplink's first USB modem. And so this doesn't have that serial functionality that we talked about or that I/O functionality, but oftentimes you've got a network appliance that has a USB port specifically for this out-of-band connectivity. And so we've got this great new USB modem that's going to be an excellent fit for those types of third-party devices that just need a reliable modem to plug into it. You know, people have done this for years with the consumer USB sticks that you can get from your carriers, right? But those are exactly that. They're consumer solutions. They're not meant to be on 24/7. They're not meant to run all the time, right? They don't have reliable drivers that enable that always-on reliable functionality so that that device is on when everything else goes wrong. And so that's what the Max adapter is going to help you when you're building these out-of-band management networks. So you can plug this into, again, a third-party device that has that USB connectivity ready, and you'll have this great high quality, reliable modem that you can use for those types of devices. So here's an example of that on our own product. Our Peplink switches have a USB port specifically for out-of-band management, so that maybe you've deployed Peplink switches in a network that doesn't have a Peplink router. So now you've got one more path to get that switch talking to InControl so that you can see what's going on. Oftentimes switches aren't just a LAN side device, right? If you've got a more complex network, you might use a switch dedicated as a WAN switch, or you might split ports and VLANs off so that you've got LAN and WAN functions going on to that switch. So getting into switches remotely in these kind of disaster scenarios can be a really, really helpful tool. And so again, all of our switches have these USB ports on them so that you can plug modems like our new Max adapter into them and get to those remotely, even if you don't have a Peplink router upstream. So here's our switch portfolio. Got 8, 16, 24, and 48 port options. So lots to pick from there. And again, you can throw these into any non-Peplink network and get that nice out-of-band management capability just by plugging in a modem to that USB port. So let's look at the big picture here. You could have a lot of different deployment scenarios, but you need this common management network regardless of what's out at your sites. You could have third-party routers, you could have Peplink routers, you could have Peplink switches. You need all these devices to have a separate path to get to these management interfaces, so that if you've got a cable cut on your primary links, whatever the problem may be, you've got a reliable secondary path to get in there and get troubleshooting and figure out what's wrong. More and more, you know, this has been done for a long time, right? Large enterprises, large public safety entities have had these kind of out-of-band management interfaces, but they've built them sometimes on dial-up banks, they've built them on ISDN networks, and so whether it's an old deployment or a new deployment, there's a huge demand for modern, resilient out-of-band management connectivity. And so companies more and more, especially with COVID now that they can't get people into these facilities as readily, they're really trying to find ways to either upgrade that out-of-band management infrastructure or just add that to their network deployment right now so that they can operate with less staff on site whenever they need to. So we'll jump right into the feature demo here, folks. You should see this. It's a BR1 Mini. We're logged into the dashboard of it. You can see we've got two different WAN connections here. We've got the Ethernet and the cellular. We've got Wi-Fi WAN scanning, but we don't have that connected. But if we go under the Advanced tab, you can see down here under Miscellaneous Settings, there's a section called UART. If you don't see that in your router, you probably don't have a router with this serial functionality in it. So just double check the model you've got if you don't see that in there. By default, this is off. So if you enable it, that will enable this functionality. There's a few security settings here, so you can control which devices are allowed to access this. So you can specify specific IPs or subnets that are allowed to access this serial port functionality. So you've got some security controls where you can restrict access to it. In my case, I'm not doing that. And then there's a web console here, so you can enable or disable the web console. And so I will zoom in a little bit here. Hopefully you can see this. This little tooltip shows you how to access this web console. So you just go to this URL. And then you need to just be aware of the access policy settings for your web admin before you try and reach this. So I'm going to jump over to that quick. So this is just the System tab, and then the very first one is Admin Security. So we've got our username and password. Hopefully you've changed that past its defaults. We force you to if you haven't. So make sure you've got a secure password before you do this. One thing to note, authentication method. For those of you that don't know, our router logins aren't limited to just this admin username and password or the read-only username and password. You can integrate with larger user accounting databases like Radius or TACAX Plus to give you more centralized account control. So you can integrate this with a larger enterprise system so that you've got unique user logins to reach these functionality as well. But the more important thing that I want to talk about here is just the security side. So we've got the web admin access right now. I've turned on to LAN and WAN, so I can reach it from both sides of the network. I've got it set to HTTPS only, and it's on the standard HTTPS port 443. So those are just things that you need to know and you need to have enabled before you can reach this remote serial console. So we'll go back to that page and just take a quick look. Like I said, that information is just right up here. And so in my case, I've got a private network built up that we'll talk about later here, but I don't have to reach this from the public IP. I can reach it through our private network here. And so if I pull that up, you can see it says it's connecting to my Max BR1. It asks for a login. This is the same router login that we just talked about. Okay, so now I'm in. And if you've ever used a serial or terminal system, first thing you want to do is probably just hit the return key. So now I get some sort of cryptic prompt here. Now, to me, I know this is a Cisco switch. I've got a Cisco switch hardwired to my BR1 via that console port adapter. And so now I'm logged into the console of this Cisco switch. So now I can enable, and we can just see what our Cisco switch config looks like. So that's pretty easy, right? And so if you've got a public IP on your device, you can do that way. If you've got a private network built out, you can do it that way. But this is just interfacing directly to the router on one of its interface IPs. Now, that's great, but public IPs aren't the best idea anymore. You want some good security built around this, and you want some convenience built around this at the same time without sacrificing your security. So we've got the BR1 Mini pulled up here in InControl 2, our cloud management system. Again, you can see the same info that we had previously. We've got some different WAN interfaces there. But if we go under settings here, after you enable this little after you enable serial to network and then enable the web console, some new things show up in InControl 2. Under settings here, you can see we've got this out-of-band management web console now. So I'm going to click on that. And the great thing about this, if you've used InControl's remote web admin, it works exactly the same way. So you can have a non-public IP, you can have a cellular connection that doesn't allow any inbound access, and you can still reach out to the serial port through InControl. So this closes a lot of security loopholes. You don't have to expose this directly to the internet. You can do this all privately through InControl. Now I think it's upset because I've got the web console open on another window. It's not letting me access that port for some reason. But regardless, you can see we're extending that same UART server through our InControl web proxy. So you've got an easy way to get to that if you don't want to expose it directly or you don't have a private network to manage it through yourself. So next up, we're going to talk about the router's command line interface. So I'm going to go to peplink.com and just show you this. I thought I would get there that way. I'll do it the hard way. If we go under support, firmware downloads, and go all the way to the bottom, we've got some nice supplemental materials down here. Under the miscellaneous section, there is this command line's SSH reference guide. So we'll download that, and I'll show you that quickly. So our routers have a built-in command line interface that you can do a lot of different things with. So you can access a lot of the things that you might access in the router GUI or from InControl, but again, you can get to this via SSH, via our command line, so that you can do this maybe in a more programmatic way. If you've got some automation or some scripting built, you can come in and grab some of these parameters or trigger some of these parameters. So there's lots of troubleshooting tools for our product directly, but there's new functionality that will be going public in a later firmware version here that will let you do some other out-of-band management capabilities. So I'm going to show you how to use these right now. So if you go under the System tab, we were here earlier, there's this CLI, SSH, and console. So again, if you've used Peplink before, you know these tooltips are full of great little nuggets. If you've not used Peplink, click on the question marks. They answer a lot of questions. We try and put very helpful information in these as much as possible. So I encourage you to click on that and just help kind of understand what some of these different functions are doing. And as you can see here, sometimes there's additional settings. You might not see the setting you exactly wanted, so you've got some additional options sometimes that are exposed through these tooltips. In any case, we've enabled the CLI, SSH, and console. And again, we get to control where that's accessible from. So I've set it to LAN and WAN. I've set the port to a custom port. And I'm leaving this login grace time at default, but you can modify that if you feel that's appropriate. So there's two ways we can reach this now. First way is just using SSH. So I'm on a Mac, so I'm just going to use the command line that's built into my Mac, but if you're on a PC, you can use PuTTY or some utility like that to do SSH. And it's real simple to access. Again, I'm on a private network, so I can reach this device through its private IP here. But I'm just SSHing to that IP and that custom port number. Entering the router password, and I'm in. So again, that command line guide that I just showed you shows you all kinds of different commands you can use, but I'll show you two commands that, again, are going to be exposed in the documentation very shortly here. One of those is accessing that serial port. So I'm telling it this is a support command, and I'm telling it I want to use the serial interface, and it's mapped out to serial interface 1 on this device. There's only one serial interface. And so I'm in that command line. Remember, I just showed, I did the show run previously, and so we're just picking up right where we left off on that Cisco switch. So we can get all the different configuration parameters that were waiting to be spilled out onto that serial port last time we accessed it. So it's just another way to access that same interface. Again, depending on your customer's requirements, depending on security posture, you may want to interface that same serial port in a different way. And so we've got a lot of different ways to get at that. So I'm going to close that. The other thing that I'll show you in this same command line interface, we've got the ability to use Telnet. So we're going to log back into that router. And I don't have a Telnet device to log into here, but the syntax is pretty straightforward. So again, you can use our device as kind of a leapfrog to jump into other systems that are on the LAN side of this out-of-band management network, so that you're able to get to whatever device you need to quickly, easily, and either in an automated or a manual fashion. So again, the documentation for that CLI guide will be updated shortly so that you can see some of these new commands that are in there. Next up, we will show you the input-output functionality. So one product I'll show you here is our new UBR. So the UBR is a dual radio, really cost-effective product. It's $4.99 with 2 LTE radios. So it's a great fit if you need to build a really resilient out-of-band management network. Pretty low cost, right? It's about the cost of most single radio products out there, but you get the added benefit of that secondary cellular radio so that you can build an unbreakable out-of-band management network. So the input-output functionality is being developed as we speak right now. So in 8.1.1, the next firmware version coming out, you'll start to see a lot of this functionality fleshed out in a lot more detail. Right now, it's not fully featured, and so I'm going to show you a preview of what's coming. And I think this is really a great opportunity to open up the lines for feedback from you guys about what you want to see possible in this input-output functionality as well. So again, if we go to the Advanced tab, if your router supports it, you will see this GPIO button down, or menu item down here. So again, I showed you on that earlier slide, and we'll go back to that after we wrap up the demo here and show you which models have that in there as well. But this is the UBR. This has the GPIO functionality, but it doesn't have the serial functionality. I know that was a question that came out already. So Douglas, unfortunately, there's not serial functionality on the UBR, but it does have this GPIO capability. So in its current state, it's really limited to ignition sensing, or that's the main purpose at its current state. So in today's firmware, you can do ignition sensing with the input ports here. So ignition sensing is just simply a shutdown timer, so that you're aware of when the vehicle's on and off, so that you can keep the router on when the vehicle's on, and then when you shut the vehicle off, you can set a shutdown timer so that you allow some amount of connectivity to remain, and then you're not going to drain your battery and let it run all day, all night. So that was the original feature added to this bank of ports and this functionality. But you can see now in this firmware, we've got this new I/O section down here. And so we're adding a few different capabilities here so that you'll be able to either trigger something or sense something. So we've got digital input, and we've got digital output. So with WAN status, you can trigger that output pin to either turn on a light or toggle some sort of functionality on a downstream device based on the status of your WAN connection. Now you've also got the ability to just manually toggle high or toggle low. And so these are functions that will be exposed through the device API. Again, that functionality is being built right now, so documentation and firmware with that capability will be coming out soon. If it's an urgent item for a project you've got, definitely reach out to us right away, and we'll help you get access to this if appropriate, and again, help you weigh in and help shape the functionality as we're developing it. We've also got an analog input so that you can measure voltage. So if you've got external system that you need to measure voltage on, you'll be able to read that, and then you'll be able to view that again via that device API, so that you can see again the voltage of some external system. So like I said, this is functionality being developed right now, more to come, but please do weigh in either directly over email or on our forum if you've got ideas for how you want this to work. Okay, so the last item I'm going to show you is we're going to talk about private networks and speed fusion. Like I said, historically, out-of-band management networks were built around either dial-up technology, ISDN, private circuits, right? Old, expensive, kind of cumbersome technologies. A lot of those technologies evolved over the years, and they really migrated to some sort of public IP type system, right? Somebody would deploy a cellular router, put a public IP on it, and then that's how they would manage their out-of-band management access. And I think a lot of us know that's probably not the best idea anymore. There's been many examples of public IPs on cellular networks just causing cost overruns or all kinds of problems, right? So we've seen people really migrate away from that public IP type of out-of-band management system and really start to embrace VPN technologies and private networking to manage these out-of-band management networks, or to access these out-of-band management networks. And so that's just yet another great application for speed fusion. So you can build a speed fusion network so that you've got access to all the different devices on your out-of-band management network segments. So here I've built a speed fusion VPN between a couple different routers and a fusion hub. So I've got a router connected to my computer here. This Max HD2 is connected to my PC, and then I've got that BR1 Mini that we were logging into the Cisco switch on, and then I've got that UBR that we've got the GPIO functionality on. So building a SpeedFusion network is just as simple as click, click, click. I've done it before here so that it's all up and ready. But it literally took me 3 minutes to build this network, and it probably took another minute for the connections to come up. So, you know, less than 5 minutes, you've got a global VPN built up so that you can securely manage your devices remotely. I won't click finish because I've already got this built, like I said. But again, when I was logging into these devices, I'm using this 192.168.150.1 address because I'm on this private out-of-band management network. The other cool thing is I can access other devices, right? I don't have to just access my Peplink BR1 Mini. If I've got an HP server that has an ILO interface on it, I can reach that directly now from this network. So I can log right into that web lights out management port interface, and I can reboot that server. I can do a screen view of that server. I can do all of that remotely through this SpeedFusion private network. But it doesn't have to be SpeedFusion, right? Oftentimes you're coming into networks that are already existing, right? You're trying to integrate into something else that's there already. And so we support all kinds of industry standard VPNs as well. So you can just use IPsec. So if you've got some sort of larger out-of-band management network, you can connect the BR1 to that IPsec network. You could use GRE. We've also just launched the new OpenVPN WAN client. So if your out-of-band management network is already built around OpenVPN, you now have a license that you can purchase to drop a Peplink right into that OpenVPN network as well. So you've got several different ways that you could build this nice private secure network for your out-of-band management. Again, you can use SpeedFusion. That's obviously a great choice, but you don't have to. You can integrate with any industry standard VPNs as well. The other topic that I'll mention here is just, you know, the relevance of SpeedFusion is really important here, in my opinion, because you can build these out-of-band management networks in even more resilient and more cost-effective ways when you start to leverage our capabilities. So, for example, you might plug this BR1 Mini into the primary network on your remote site, right? You might use that as the primary WAN for this out-of-band management. But then you've got things like drop-in mode, and you've got things like hot failover so that you can fail over to cellular. So you can save yourself data on those cellular connections if you need to, right? You can just drop that cellular connection down to priority 2. If that's how you want to configure it. So you can work with the existing infrastructure and leverage that as much as possible without having to spend a bunch of extra money to bring all these extra interfaces in. The other cool thing, Wi-Fi is WAN. If you're in data centers, oftentimes there's public Wi-Fi there, or there's just public Wi-Fi nearby where your location may be. So you can use a Wi-Fi network to build this secure SpeedFusion tunnel over. Again, get all those private network management benefits, but again, doing it securely over SpeedFusion instead of directly over these interfaces. So that covers all the topics I had today. Again, I said I would go back to the slide that shows the models here. So again, you can see with the icons here, the ones that have the serial functionality and then the ones that have the I/O functionality with the 4 square icon there. It looks like we overlooked the UBR, which does not have serial, but it does have the 4-pin I/O. So just to be clear, the UBR is capable of that GPIO functionality. So I'll open it up for questions now. Okay, so I see the first question here is the UART serial function accessible from the Peplink CLI, particularly via IC2. Yes, I touched on that a little bit, but just to be clear, that is absolutely accessible using that support serial #1 command that I showed you there. Again, that'll be added to the documentation shortly so that you can reference that anytime you need to. But yes, you can access the serial port through the router's SSH CLI. I'm realizing I forgot to show you one more way to access that CLI as well, and that's through IC2. If it sounds redundant, it might seem like that, but I'll show you that real quick here. Okay, so we showed you, most of you are familiar with Remote Web Admin. We showed you the out-of-band management web console. That's to go directly to that UART interface. And then when you enable the web CLI in the router GUI, this one shows up here. So again, you can get to that same CLI interface. Instead of using SSH, you can use the InControl web proxy to get to that same interface. So multiple different paths to get to the same places depending on what's convenient or required for you. So again, this is the Peplink router's command line interface accessed through the InControl remote web proxy. Okay, next question. Is there a multi-port console server you would recommend to use with, say, a BR1 Mini? I don't have a good answer for you on that yet, but I would keep your eyes on our website and our email notices, because there might be more coming in this department. So I don't have a specific recommendation there, but definitely stay tuned. Okay, another question. What firmware was TACAX introduced? I don't know, but when we get to the bottom here, I'll try and find that answer quickly, and hopefully I can get you an answer online here before we drop off. Another question was the SpeedFusion demo connection, was that connecting to Azure? Yes, I was using a Fusion Hub in Microsoft Azure. I also have one in Google Cloud in this environment, but yes, the one we showed you today was using Azure. See another question about the InControl 2 appliance. The InControl 2 appliance is a legacy product. We don't sell it as an appliance anymore, a hardware appliance. We sell it for the same purpose, just as a virtual machine for lots of different platforms. So if you're having problems with that older InControl 2 appliance, you can reach out to our support team, and we'll definitely be happy to help you with that. Another question on the GPIO is that input status and output triggering accessible via IC2. So today, no, but again, this is the exact kind of feedback that we want to see and hear from you folks. So, you know, it makes perfect sense to me that would be extended there. And so I think that's something that we will raise with the IC2 developers as the functionality is built out in the web GUI, the device API, and then again, see what we can extend to the cloud side as well. The other thing that I'll just mention here, for those of you that have used our APIs, there's an InControl 2 API and there's a device API, so direct to the router API. You can use the device API through InControl 2's API. So there's an endpoint in the IC2 API that lets you access endpoints in the device API through that same kind of web proxy that we were pulling up some of these other different interfaces. So if you know what the heck I'm talking about there, take a look at that, because that can expose some additional functionality through InControl that you might not have been able to reach previously. And then I see another question here or comment just about the SMS reboot functionality. I'll just point you guys to that as well. There's a SMS control guide as well here. So there's some just basic functionality that you can enable on our routers using SMS. So just another way to do out-of-band management with our devices, so that you can control a device remotely via SMS. Maybe it's not responding in other ways. So sometimes you've got a carrier issue. Sometimes that data plane isn't working, but the SMS plane of the cellular network may still be active. And so you can get some different status information. You can set APNs if you've got an APN that's maybe not configured properly. You've got just a handful of useful kind of last resort commands that you can use via SMS on our routers. But David, I would encourage you to just open a support ticket if you're not able to utilize that functionality properly. I think that covers all the questions for today. So I will look for this TACAX answer real quickly before I let you go. I know that was in one of the recent versions, but I can't recall exactly which one. Just give me a second and I'll look that answer up. Okay, so that was in 8.10, our most recent firmware version. So that's a new feature just very recently here. So that's, if you're surprised by it, that's probably why it just came out probably about 2 months ago. All right, folks, thanks again, and enjoy the rest of your day.